Yeah, hello and welcome to this After Effects tutorial for marmoworld.com. My name is Matthias and today I give you an in-depth overview over the inverse kinematics iExpressions that are part of the physics bundle. In general, inverse kinematics is very useful for character animation. What you can do is define so-called bones, and the expressions calculate how these bones need to move when you move the goal points. What this means is the following. We have here some examples for different so-called IK chains. So we have here one leg and here another leg and here we have an arm. And first of all, we can have here this target point that I can move, and you can see when I move the target point, the entire arm moves accordingly. And obviously we can do the same here also for the feet. And notice, for example, that the foot here always stays horizontal. No matter how I move it, all of this is automatically calculated by the expressions. And also I can do stuff like moving here the entire body, and you can see in this case, for example, the feet stick to the ground, whereas the entire arm moves. And this simplifies animation of such bodies quite a lot. Another thing that I also cover is how to combine this with Puppet tools. So in this example, you can see we have here again such an IK or inverse kinematics chain with these three elements here. And again, I can move my arm, and you can see that the puppet pin or the puppet tool that I use to actually deform this arm here nicely works together with our bones. So let's start with explaining you how all of this is built. So I start with an empty composition here that has just some background layer. And I also bring in here some image for such a bone segment. You can, of course, just use solids or whatever you like. It works with any kinds of layers. And first, I need to create here three elements. Let's name the first one upper arm, and then I duplicate it, or actually before duplicating, I move its anchor point, because this is really important, that the anchor point of the element is at this end here. This is something you always have to keep in mind when you set up such an element. Then we duplicate it, call the second one lower arm, and duplicate it again, and name the third one hand, like this. Now we can set up our parenting, or maybe let's first scale them down a bit. Maybe like this. And now we do it such that the hand is the topmost, and then the lower arm is in the middle, like this, and the upper arm is here. And make sure that they are nicely attached to each other here, like this. Doesn't need to be 100%. And now the second important thing after setting the correct anchor point is setting the correct parenting. The upper arm must always be the parent of the lower arm. So the parent of the lower arm is the upper arm, and the parent of the hand is the lower arm. This is because now, without any expressions applied yet, if we rotate the upper arm, you can see everything rotates. If we rotate the lower arm, the hand rotates with it, and the hand just rotates for itself. This is just the reason why we need this parenting structure. And of course, now we can also scale these three. Let's say the hand is obviously the smallest, and then let's also say the lower arm is a little bit smaller than the upper arm. Now we have our nice arm here. And now for the inverse kinematics to work, we also need a goal layer that says where the tip of the hand, or actually here, this anchor point of the hand, should point to. So we create a new null and call this here hand goal. So now we need iExpressions, and the iExpression looks like this. It has a huge library of far over 100 expressions that are also continuously extended. And in the physics category, we have real-time physics. This means really fast computing physics simulations. And there is the inverse kinematics. And we have inverse kinematics arm with 2 segments and inverse kinematics arm with 3 segments. And if you look at the help text below, this one says the 2 segments is for an arm or leg consisting of an upper arm, lower arm and hand. Whereas this one here with 3 segments consisting of an upper arm, middle arm, lower arm and hand. Yeah, we normal humans have 2 elements in their arms, so therefore only upper and lower arm, the 2D version. Using this iExpression is actually really simple. All you need to tell the expression is what layers it should work with. So it needs to know how does the upper arm layer is named, and we named it upper arm. So I just write here upper arm. For the lower arm, lower arm, and then for the hand, we named it hand. And for our hand goal, this is the target point where the hand should point to, we named it hand goal. And all you need to remember is that you need to apply it to the hand, lower arm and upper arm. So make sure you have no properties selected, just the layers themselves, or alternatively just their rotations, and click apply. And now you can see the arm deformed. And if we move now our hand goal, all the arm nicely moves with it. So now maybe let's bring this into a shape that looks more like a normal arm actually, where the shoulder is at the top, not at the bottom. Oops, I accidentally moved here this. I should always move the goal point. You can see if I move the goal point too far away, the arm stays perfectly straight. And also note that by default, the hand is always horizontal here. Yeah, you can change this behavior. If you want the hand to actually rotate with the arm, you can deactivate this rotate hand here, apply it again, and you can see if I now move it, now you can see the hand always points here towards our goal point. Yeah, or in other words, it always, when the lower arm rotates, the hand rotates with it. No matter which of these options you choose, you can still keyframe your hand on top of these decisions. So I can go to the rotation of it, and you can see the expression is applied. But you can say here it should have a rotation of 0. And 100 frames later, it should have one of 90 degrees. You can see now it rotated here. And you have now this animation, and no matter how you animate it, you can see now it's again straight, and here it rotates 90 degrees. And again, if we take this decision to rotate the hand and apply the same again, apply, you can see now here it's perfectly horizontal, and it stays now perfectly horizontal no matter how I move my arm. But still, you have here your keyframes. So from now on, it will not be perfectly horizontal, but perfectly vertical, always pointing down. So these are your choices, like either rotate the hand automatically, such that it always preserves its position, or don't rotate it and let it automatically follow the lower arm. Also, we have this flip option. You can see currently this looks, you have a corner here going to the left. If I enable the flip and apply this again to the 3 here, apply. Now you can see it points to the same point, but from the other side. Yeah. This is, oops, I again moved here something accidentally. So when you move, make sure to always move just your goal point, like this. And now let's make something maybe more interesting. So first, let me undo this flip here and say this here is our hand. And let me remove here these keyframes for the rotation again. So this is our hand. And now we also want to add some bones for the legs. So we can duplicate this entire thing here. And maybe also the arm is a bit large, so you can just scale the upper arm as scale. You can see everything scales with it. You can see the arm behaves really nicely no matter how you scale it. Yeah, It's not that the expressions will break or something. Really nice. And now we want to duplicate it for the legs. So we select all the 4 layers, the goal, the hand, the lower arm, and the upper arm, and duplicate it, and move the duplicates at the top, like this. And now you can see for these duplicates, it's not working as expected. If I move my upper arm, you can see the expression does not seem to work, and it's still back into its original state. And this is simply because you need to update here these names. Yeah, I mean, these new layers are called hand 2, lower arm 2, upper arm 2, and therefore they are not working on these layers. So let's give them also a bit more meaningful names. Let's say we have here foot, lower leg, and here upper leg. And this is a foot goal. And then also we need to adjust these here. Note that changing them here does not change these existing expressions. It's always just after you apply again that these take effect. So this is then the upper leg, this is the lower leg, this is the foot, and this is the foot goal. And now we can simply select the foot, lower leg, and upper leg and apply it. And it says, please enter at hand goal layer an existing layer. Oh, you see I had a spelling mistake here. There's no space between foot and goal here, but there's one here. This is a very nice thing that the iExpression will check this. So I enter it here and try to apply again. And this time it works. And if I move now my foot goal, you can see this time the foot is nicely following this. And I can now take my upper arm and or upper leg actually and move it where it should be, say about here. And now you can see if the hand is going in this direction, we actually want to flip the leg to go into the other direction. So select the 3 again, hit apply. This time it seems I have to select a wrong property here. Yeah. So I say, iExpressions also detecting this, and I say no, I don't want to apply it, and make sure to have really just selected these 3 layers and no properties of them. Apply. And now we have here our leg and here our arm. Maybe we can make the leg a bit larger. So I scale it, the upper arm a bit. I always just scale the upper because the other ones scale with it since they are parented. Yeah. Like this, it's looking nice, I think. And now I want to add a second leg. So I can again duplicate all of them, move it to the top, and adjust my expression to say upper leg 2, lower leg 2, foot goal 2, and apply it. And I accidentally applied it also to the foot goal. This does not matter actually. Yeah, it's just ignored. But you can see here, my feet are now nicely. I can fix this by simply deleting it on the rotation of the goal. Yeah, the goal does not really need it. I can just select it. Here's the code and delete it, like this. And now my rig is already looking pretty good. So I can move my 2 feet here, and they are moving accordingly. I can move my hand. And what I now, oops, again, I accidentally moved the hand and not the hand goal. To avoid this, a good idea is to later lock all layers except for the goals. Like this. And now this cannot happen anymore. Yeah. Now we have here our hand and here the feet that I can nicely move. What I also want to have is like a controller for the entire body. Yeah. So for this, I just add a new layer and call this body master. And for this body master, I place it here roughly in the middle of my body. And now I parent my arm and my legs to the body master. So I need in particular to use the upper leg gets parented to the body master. And then of course the second upper leg, this one. And finally also the upper arm. Yeah, these are like the 3 points where the arm and the legs are attached to the body. And now if I move the body master, you can see I can move the entire body and still the hand and the feet stay in place. Yeah, you move like the center of your body. You can, for example, also rotate it. Yeah, R, so I can rotate the body however I like. But the hand and the feet stay where they are. For the feet, this is most likely also what you want. For the hand, it might be nice if the hand moves with our body. Yeah? This means you can still move it on its own, but when I move the body, it maybe should move with it. And this is also no problem because you can also parent these goals here. So you can say your hand goal, this one is also parented to your body master. And now you can see if I take my body master and move my body, the feet stay where they are and the hand is moving with it, and still I'm free to move the hand independently. So by that you can set up pretty advanced rigs by just parenting and these nice inverse kinematics or iExpressions. Okay, now most likely you do not all the time want to have animations where each of these elements here is a separate layer, but more often you want to combine this with the puppet tool. So how is this working? So as a puppet tool example, I have prepared already this little caveman here. If you look at it, it consists of 2 layers. One layer is just this arm, and the other layer is the background behind it. And now obviously we want to add some bones to this arm in order to animate it easily. And the way we do it is we copy from the previous example some like the arm here, so upper arm, lower arm, hand, and hand goal. I need to unlock them here. So I just select them all, go to Edit Copy or Control C, and go to the new composition here and go Edit Paste. And you can see due to the different composition size, it ends up here at a different position. But if I move it here and move the goal, you can see it's still functional, so it survives such a copy and paste easily. Okay, let me just show the entire thing here. And now we need to fit this arm into the original arm. So we let me first actually move the top of this bone here to the top of the arm. And then obviously we need to scale it down. So we scale, maybe the upper arm should be even smaller, like this. Now you can see, maybe I move it a bit up, and now it looks like it could be a little bit larger. This is obviously a little bit of playing, maybe like this. And now the lower arm needs to be a little bit larger, maybe like this. Okay, now we have our IK chain here that has roughly the correct size. And now the next thing we need is that we want to attach this to the arm here, to this layer, with the help of our puppet tool. So for this we first create 3 puppet pins. So we select the arm and click here we want to have a pin, and here we want to have a pin, and here we want to have a pin. And what you would do if you had no inverse kinematics, is you would just grab these points and try to animate them manually. And this is pretty complex because if you animate it, it's really easy to stretch it too long or too short, or get some weird positions, or like to go here in the wrong direction. The arm will never be able to make moves like this, or stretch the arm so long, but with if you just animate the pins, it just happens really easily, and you see everything here looks strange and weird if you try to animate it manually. So it's much easier to do this with the IK chain. And what we do for this is we connect them to our bones, these puppet pins. So this means in our puppet effect here, we have our mesh, this one inside the puppet effect, and this has deform points for these 3 pins. Yeah, pin 1 is this one, pin 2 this one, and pin 3 this one. And now we need a special expression from our library again. Again, it's in the physics simulation real-time inverse kinematics, and it's called link puppet pin to layer. And what this does, if you apply it, is it links such a puppet pin. And the only thing you need to remember is that if you select a puppet pin, you don't need to select the puppet pin itself, but its position. And it links it to a layer of a given name. Let me just make here some more space. So we had here our layers upper arm, hand, and lower arm. And this first pin, pin 1, is this one here, and we need to link it to our upper arm. So just select enter upper arm here, select the position of it, and apply. And currently nothing happens because it was already in the right position. But let's continue. We select the second pin position and say it should be linked to the lower arm. Apply. You can see a little bit it moved, but not too much. And then the third pin, we say this should move to the hand, and see currently our puppet pin is here, but our hand is here. Yeah, apply, and you see immediately it jumps back. And now we can really take our hand goal, and let me lock these again here to be sure, like this. And now we can move our hand, and now the animation of the hand is much more realistic, because if I move here too far with my goal, let me just enlarge this here for a moment. If I go too far away with my goal, the hand is not stretched, but it stays where it is. Yeah, this is just natural. And you can like flip the hand or turn the elbow here in this direction, but you cannot turn it in the other direction. Yeah, it will always turn in this direction no matter how high I move my arm. So you get a really much more realistic movement of your arm if you do it with the help of the inverse kinematics than if you try to do it manually. Manually, it will very quickly look just stretched and squashed and not really moving naturally. If you want to make it even more precise, you have more control. If you want to add more puppet pins, yeah, this is no problem. Let me just explain you how this goes. Let's say we want to add another puppet pin here in the middle of the upper arm because we want to control the position too. Yeah, for this I can just create a new solid or a null object maybe, move it to the position where I want the pin to be, like here for example, rename this maybe to extra pin, and now add another pin to our arm layer. Yeah. So I select here the puppet effect, and we have already these 3 pins, and now I say I want to have an additional pin here. So I just click here for this additional pin, and now in our puppet effect we have in our deform properties here our 4th puppet pin. I select it and say this should be linked to our new extra pin layer, to this one here. So extra pin, and click apply. And now if we move our hand, you will see it will look very strange because obviously let's move our hand goal. Obviously this point is not moving with our rig. Yeah, this is an interesting thing, that the puppet pin expression here, you can use it also without inverse kinematic. If you just have whatever else other reasons to move your to connect puppet pins to layers, you can do it with this one here. But in this particular case, obviously we want this null to move with our arm. Yeah, so let me undo this here again quickly. And we do this by just linking this or parenting this extra pin again to our upper arm with which it should move, like this. And now you can see our extra pin here nicely moves with our arm. And the good thing about this is that now we have full control. Like we can say, okay, if we want this pin to be more like here, to shift this upper arm a bit more to the right, we can fine tune this here, and still everything moves nicely with our animation here. And you can do any kinds of these fine tunings by adding more pins to your animation. Obviously, once you're happy with your rig, you can just shy all these layers and make them invisible. So we don't, except for the goal points, we don't need to see the bones here actually. Yeah, they just need to exist, and they also should not pollute here our interface. So we can just make them shy like this. So this extra pin can disappear, and here upper arm, hand, and lower arm are not needed, such that now we have a nice and clean composition, just where you see the hand goal, arm, and background. And you can nicely animate your arm with your hand goal, and everything animates as expected. Okay, there's one Inverse Kinematics iExpressions that I haven't shown you so far, and this is the IK arm with 3 segments. This is the same as the 2 segments variant, except that your arm might consist of an upper arm, a middle arm, a lower arm, and a hand. Yeah, so this is, I don't know, if you want to create any kind of fancy alien or whatever, you can use this. Yeah, apart from that, usage is exactly the same. Just enter the names of the different layers and apply it to all of them except for the goal point. Okay, that's it for this tutorial. I hope you learned something useful about how to use Inverse Kinematics expressions. And yeah, I'm looking forward to see you in the next tutorial.